So on this web page, what you're accessing is a GitHub repository. Um, for those of you who aren't familiar with GitHub, that's okay. Um, the basic idea with GitHub is it's a place to make, it's particularly used by code and software developers to make code available and to version control the software that you're working on. So it's a good way to keep track of the version history of the files that you're working with. In this case, I'm simply making available the files for you to access in a public forum. These are the files that we're going to be working with, and we're actually going to be interacting with something called a Jupyter Hub. So you'll be running, if you'd like to, Python on an external server. I won't actually expect you to have Python installed on your own computer. And in this particular workshop, I'm not going to be talking about installing Python. Since there are so many of you and since we're kind of socially distanced, that can kind of be a headache all in itself. If you'd like to install Python yourself later and have any questions about the process, you are more than welcome to send me a separate email after the workshop and I can get you up and running. For the moment, if you scroll down this webpage, I've included two links. One, for those of you who are with UCLA, I've made available this Jupyter Hub through the Institute for Digital Research and Education, which is where I work. You can click on the launch into Jupyter Hub and it will launch, it should launch a separate, well, I guess it stays in the same browser tab, but it, let me log out of this so you can see exactly what it does. When you click on the link, it should take you to a Jupyter Hub and require you to authenticate into the system. When you authenticate into the system, you'll see a screen like this. So you'll click on the orange button and then it will ask you to select an identity provider. In your case, I'd recommend that you choose UCLA. That's probably the most straightforward authentication method. You're also welcome to choose Google if you want to, but you do have to authenticate with your g.ucla.edu email address. After you've logged on, you should be taken straight into the directory with the files that I'm going to be using. So in that case, it will be in a folder called Numerical Python Part 1. The Jupyter environment is very easy for it, interactive computing. In this case, you're accessing an isolated environment for each one of you. The files that you're seeing are your own copies of the files. You're free to modify them however you want. And you're free to access this Jupyter Hub after the workshop if you want to continue interacting with Python. The way it's set up is basically like a web server where you access an isolated environment for you on the web server, and Python is already installed along with all of the packages inside of this isolated environment that's created for you. Once you land inside of this environment, the first thing that we're going to be working with is this file called starthere.ipynb. So if you're following along, I'd like you to click on that. And then I'm going to pause for the moment and just make sure that everybody who wants to has been able to access the files and log in okay. If you haven't had any trouble, please let me know in the chat window or unmute yourself. Okay, great. It looks like I'm going to assume that everybody is working along okay. You're of course welcome to just watch what it is that I'm going to be doing and then come back to these, they're called Jupyter notebooks later, and go through the through the cells yourself afterwards. Everything that I'm going to be typing, I will make available after the workshop as well. So just in terms of the basics, it's first just important to talk about the language that it is that we're going to be working with. So Python is a high-level computer language which is used in a large variety of different applications. This is a web page from python.org, one of the main Python sites. And here, just on its website, it lists a kind of brief sampling of some of the different applications for Python. One of the main applications is web and internet development. So it's used, there are complete web frameworks that are written in Python. It's used for a lot of text processing and scraping of information from the internet. Python is widely used also in scientific and numeric computing. So that's the main topic of this series of 3 workshops that I'm going to be leading. The first one today is mainly just about Python, but then next week on next Friday, I'm going to be talking some more about the numerical packages that are available in Python for you to use. I'll be talking about NumPy and SciPy and Pandas in particular. Python is also used a lot for education. And in fact, the Jupyter Hub that we're accessing is largely written with Python code itself. So it's kind of written with a combination of Python and JavaScript. The JavaScript is responsible for controlling what you see on the front end. But a lot of the code that's incorporated into Jupyter is written in Python, and actually Jupyter is used quite extensively for educational purposes. Python is used for desktop GUIs, for a lot of different software development, and even for business applications. So Python is one of the most popular programming languages that there is. We'll come back here. It was developed by Guido van Rossum and released in 1991. So it's been around for quite a while now. And some of the things that make it very popular is that its simplicity and readability. So it can be a very easy language to learn, but it also has a lot of the power that you expect when you want to code up programs that solve some problem that you want to solve computationally. I have listed here a couple of the aphorisms which are part of Python's core philosophy. So beautiful is better than ugly, explicit is better than implicit, simple is better than complex, complex is better than complicated, and readability counts. You can kind of see here in these aphorisms that Python is really developed with an intention of kind of this ease of use, and it's intended that simplicity and readability really increases the productivity when you're working with the language, because it can be very easy to learn, it's very easy to read, that can make it very easy to maintain, and it can make it very easy for you to develop code once you have a concept of what it is that you, the concept of what the problem is that you want to solve with the programming language. Python is, let me actually make this bigger. So Python is an interpreted, object-oriented, high-level programming language with dynamic semantics. Part of deciphering what this means. So when you say that Python is an interpreted language, what it means is that you can type Python code, and when you run it, you run what it is that you've typed. You don't actually have to compile what you've written into an executable file. So with languages like C++, say you would take the text file with the code that you've written inside of it, then you'd compile the code and it would convert it into an executable file. With Python, you don't necessarily have to do that, although you can compile Python code if you want to. But the Python code that you write can simply be executed by running the Python script that you've written, and the script gets executed by this thing called the interpreter. It's object-oriented. It's a high-level programming language, which means that it's intended to be human readable. And the dynamic semantics, what you'll notice is that you don't actually define the type of variable when you use it in Python. So in other languages, say you might specify that an integer, say, is an int, or you have floats or strings, and you have to declare a variable before you use it. You don't have to declare variables when you use them in Python. It tries to ascertain what type it is by how you're using the variable in your code. And then finally, another interesting tidbit, Python comes from Monty Python's Flying Circus rather than the Python snake. So some of the more amusing examples that you might see in Python tutorials kind of grab material from Monty Python. And we'll actually grab some material from Monty Python too, which there are various ways to run Python code. So I mentioned that Python is an interpreted language. You can run Python code interactively at a prompt. This is what we're going to be doing shortly, and I'll show you this first. You can write Python code into a separate file that contains all of the code that you want to execute it, and then run that script at once. There are a lot of different interactive development environments that you can also run Python inside of. What we're going to be talking about today is mainly the kind of core syntax of the language. And we're going to give you a flavor of how it is that you write Python code. I'm not going to focus so much on what you might want to do in a production environment. We're just going to kind of be very practical from the beginning and just get you something that executes so that you can kind of get a flavor of the language. So what I'm going to do now, and you're welcome to follow along with me if you'd like, I'd like you to go to the web browser page that shows your file menu. And up on the upper right, you'll see a new button, which you can click. And then there's an option to open a terminal. So for those of you following along, open up the terminal. And you should see a screen that's something like this, where if you click on it, there's this, there's a cursor on it. This entire thing is just a prompt for where you type commands. To run Python, all you have to do is type Python and hit enter. And then you'll be launched into the interactive Python environment. So these three carets here, or I guess greater than signs, are the prompt for where you can enter in a Python command. This information up at the top just tells you what kind of environment you're in. So the particular version of Python that we're running is 3.8.5. Along the way of Python development, there have been successive versions, just like versions of Windows or versions of MS-DOS. There have been versions of Python. Recently, for a long time, there was kind of Python 2 and Python 3 that were being developed and used kind of in coordination with each other. Python 2 is no longer being supported. Python 3 is the way to go, and it's already gotten up to Python. It kind of started out at Python 3.0, 3.1, and worked all the way up to 3.8. I think it's on 3.9 now, and yeah, so there's a question about how I got here. If you go to the file menu in your Jupyter dashboard window, up here on the upper right, there's a new button. If you click on the new button, you'll see a drop-down menu. Select terminal, click on the terminal, and that will open up the terminal for you. The most basic thing to do with Python in this environment is just to use it kind of like a calculator. So you can do basic mathematical operations with Python, just exactly like how you might think of doing them inside of a calculator. So if I type 2 + 2 and hit enter, that gets interpreted as a little bit of Python code. Python runs this little bit of code, and then returns to you the output of what happens when it runs that. So perhaps kind of self-evidently, the output of 2 plus 2 is 4. You can do multiplication with the asterisk sign. 2 times 2 will give you 4. You can also do division with a slash. 2 divided by 2 will give you 1. In this case, what you see is a float result. So normally, an integer is something like a whole number, and a float is something which is has a decimal point and a certain decimal expansion. This kind of changed between Python 2 and Python 3. You don't have to worry about that, but in Python 3, division can be an operation with floats. If you actually don't want that, if you want to keep division to be like an integer like division, you can do 2 slashes. And that will actually give you the floor of the division. So what, for example, 3 divided by 2 will give you 1.5. The floor of that is what happens when you round down the number. So 3 with 2 slashes and 2 gives you the floor of 3 divided by 2, which is 1. You can also do the modulus. Let's do 3 mod 2 will give you 1. That gives you the modulus. And then you can do exponentiation with two asterisk signs or asterisk symbols. Those are some of the very basic mathematical operations. So, Python supports a lot of different numerical computations, but all of these basic arithmetic operators, are just kind of supported in the ways that you might think that they're supported. Perhaps the next thing to talk about is simply variables. So you assign a variable with an equal sign. Saying that a is equal to 3 doesn't mean that you're trying to assess the equality of a equal to 3. It means that you're assigning the value that's on the right to the variable that's on the left.
Benjamin, hi, sorry to interrupt. A lot of us are stuck at the very first part. We're not able to enter anything.
Yeah, so you just have to type Python here. Type Python and hit enter. And then it will take you into the interpreter. Does that help?
Yeah, that's the part that I think we were missing. Thanks.
Okay. Yeah, thank you for pointing that out. Yeah, so just, you can't just execute these on the command line. You actually have to be inside of this Python interpreter. I'll show you a little later how you can execute something like this on the command line, but you do have to execute Python first to get this Python interpreter running. And then you'll know that it's running because you see this, this special prompt when you're inside of the Python environment here. So getting back to variables, this assigns the value that's on the right to the variable that's on the left. If I simply type A, the interpreter will tell me what value is stored inside of that variable, which in this case is 3. Now that I have a variable, I can treat a variable like the number that's stored in it. So I can carry out multiplication on it. I can carry out division. Any one of these arithmetic operators that can carry out on the variable, just like I would on a regular number that I type in. In addition to kind of assigning values to variables, you can try and assess equality. In Python, you assess equality by the double equal sign. So since the single equal sign is taken up with variable assignment, You use the double equal sign to ascertain whether two values or two variables are equal to each other. In this case, the value that's stored in A is 3, so A is equal to the value of 3. If I type A is equal to 4, that's false. And you can see here an additional variable type in Python, which is the variable type of the Boolean. You have true and false. And specifically with this capital letter, that's the Python value for true, and that this is the one for false. In addition to equality, you have all of the kind of normal arithmetic comparisons. You have greater than. This is going to be false because A is equal to 3. A is greater than 2, so that would be true. You have less than or equal to. I'm sorry, greater than or equal to. You have less than or equal to. So the equals always follows the greater than or equal to sign. And then simply just a regular less than. So these arithmetic comparison operators kind of follow from what you would expect from just writing down an equation, kind of as normal math.
Is there an operator for not equal to?
Yes, thank you for asking. So the not equal to is the, you use the exclamation mark with the equal sign. So exclamation sign is here considered to be not. You can also use, Python kind of has some keywords in it that are very convenient to use when you're writing code, because then it makes it kind of a little more evident what it is that you're writing. You can actually use the word not. This evaluates first what's inside of the parentheses. So Python arithmetic obeys the rules of kind of doing what's in parentheses first before you evaluate what's outside of the parentheses. In this case, it's evaluating this equality, which is false, and then it's negating that false and returning true. We'll get back to some more of these keywords in a little bit. Just so you know, when you're in the interpreter, you can type help, but this is mentioned to you when you first access it. You can type help and access kind of a large menu of help about the Python language and what it is that you're working with. For the moment, I'm going to exit out of this. The way to exit out of this Python interpreter, there are two ways. One is to say exit with the parentheses. This will call an exit function. If you type exit with the two parentheses, you'll get back to the normal prompt. This is a Linux bash shell. You don't have to worry about what that is, but you simply execute out of that and it gets you back to your normal shell environment. The other way of doing it is hitting kind of the end of file character. On my Mac, this is Control D. Typing Control and D will also exit out of that for me. If you actually type exit, it will recognize what it is that you're trying to do and give you guidance about how to exit out of this. So if you kind of forget about this, you know, just typing exit will give you a little bit of help as to how to do this. For the moment, that's all I'm going to show you about interacting with the interpreter. I'm going to jump back to the Jupyter Notebook. The Jupyter Notebook, the one that's called Start Here. This actually allows you to run Python code as well. What it does is it takes Python code that you write into the notebook. It then sends that to something that's running on the back end on the server called the kernel. That Python kernel executes the code and then returns the result back to the notebook. And then the output of what the kernel runs gets output inside of this notebook. Just to illustrate how it is that this works, we're going to just look at a simple example which kind of combines some of these arithmetic operations for you. This simple example, this is just calculating the balance after Y years. If you invest a principal, the principal amount of money, which gathers an annual interest rate of R, and you're, say that I invest $1,000 of principal into some investment, and it earns 5% interest, and I contribute annually another $1,000 at the start of every year, and I want to know what the balance is after 1 year. This is the formula which will tell me how much money has accrued in that account. So as a brief introduction for those of you who are running these notebooks for the first time, if you click on a part of the notebook, you'll see that there's a little box which is around what it is that you clicked on. That little box highlights what's called a cell. And there are two main types of cells that you're going to be seeing here. One is this type of cell, which is underneath it's written in Markdown. When you execute the Markdown, it gets rendered into HTML. Anything that looks like this cell, which has a little gray background, this is where you can type the Python code. And you'll notice text next to the box which says in, and it has the little brackets around it. This kind of tells you that there's that it's a code cell. What I'm doing here inside of this code cell is I'm assigning values to the variables for Y, P, R, and C. Then I've entered in this, which is the equation, how you would evaluate this equation in Python. So this is P times 1 plus R raised to the Y power, and then plus C, and then everything in between parentheses, and then this particular representation of the variables. In order to execute a cell, when you have it highlighted, type Shift and Enter, and that will execute the cell. In this case, what happens is when it runs the cell, the Python kernel on the back end assigns these values to the variables. It stores those variables in memory, and then it executes each one of these lines in sequence. For the last line, if an expression is just written by itself, it will do something like what we just saw in the interpreter in the shell, which is it will output the result of executing this statement. So here I've invested the principal of $1,000 at 5% interest. I'm evaluating it after 1 year, and I contributed $100 at the beginning of the year. So after 1 year, I have, say, $1,155. The usefulness of this, as we'll see, is once you have an expression like this, you can simply, well, you can copy the expression. Here I've actually relabeled the variables just to make it a separate statement. But then you can just change the values of the variables. You can execute it again. You know, if you're interested in how much money would have accrued after so many years at such and such an interest rate with the contribution of such and such, you can come back right to this formula, simply execute the cell. It will tell you, so if you're 20 years old and you want to know how much money you've accrued by 65, if you contribute, so this is like the amount that you can contribute to an IRA. After 45 years, you'll have $1 million, 1.1 approximately. The other way that you can execute cells is you can simply come up to the toolbar and click on the Run button, and that will run the currently highlighted cell. When you're in cells, it is important to know whether you can edit the cell or whether you're in something called command mode. So if you click outside of the cell, the bar on the far right, I'm sorry, on the far left will turn to blue. If this is blue, any keys that you type on the keyboard will be interpreted as operations that you want to do with a notebook as a whole, rather than letters that you want to actually enter in as text into the interior of the cell. If this is blue, to go back into edit mode, all you have to do is click in the interior of the gray box, and then you'll see a blinking cursor. What's on the left will turn green, and then you can type into the cell. So now I can say, well, I want the principal to be 1,000, not 1. And then I can execute the cell again by typing Shift and Enter, or I can come up and hit Run. So for the question, is there a way to store a function into a variable? Yeah, so we'll talk about functions a little later in the notebook. You definitely do want to know how to write functions, because that's one of the key things that you want to do when you're writing code. At the moment, well, so I hope this isn't too slow, for some of you, but it's important to kind of get the foundation of what the different variables and data type operations are before we actually get to the functions. The next important kind of data type that I want to talk about is strings. So we've talked, well, I've showed you examples where you're working with integers, or we're working with floats. I showed you Boolean with a true and false. You can also have strings. So strings are just a sequence of characters which are surrounded by quote marks. They can either be double quotes as what's shown here, or they can be single quotes. They can't be a combination of the two. It has to be uniform on one end as on the other end. When I execute this, well, here, I'll actually just show you. So the type, you can figure out what the type of a variable is by using this particular function called type. So if I type, and in between the parentheses, I pass this variable into the function, it will tell me what the type of the variable is, which in this case, Python calls the string the str type. And actually, so you don't see any output here, because all that's happened is that this particular string of characters has been assigned to the parent return variable. If I type parent return just by itself, this will act like what you saw in the Python interpreter, where it just spits out what the value of the variable is. By the way, if you're wondering where I got this string, this is from one of the Monty Python skits, where John Cleese tries to return a dead parrot to a pet store, which, if you haven't seen the skit, I highly recommend it. It's very funny. Interestingly, what you can do with strings in Python is you can kind of treat them like an array. This particular syntax that I'm showing here, where I include the square brackets with a number inside of it, will access a particular element of the string, a particular character. In this case, I have the number 1. If I look at what the number 0 is, it's the capital T. You do have to note Python numbering starts at 0, not at 1. So when you try and index strings like this, or when we later try and index other collections of elements, you have to remember that the indexing starts at 0. The first character in the string is the capital T. So parent returns 0 returns the capital T. In addition to indexing it like this to get individual elements, you can get a subset of elements by doing something called slicing. So rather than including a single number in between the square brackets, if you include a number and then a colon and then another number, it will get everything in the range of those particular numbers. In this case, it can be a little non-intuitive at first that, so here's the string. This is the 0, 1, 2, and third character. When you do slicing like this, Python will not include the last numbered indexed element. So it only returns THI because it collects the 0, the first, and the second, but then stops at the third.
Hi, Benjamin. Are you hitting enter each time to get the output, or are you hitting run?
You have to type shift and enter at the same time.
Okay, thanks.
Sure. And you can also run, if you'd like, by this run at the top. That'll work too. So if you actually want all 4 of the characters, you do have to include one index past the end of where it is that you want to include it. So this is the 0, first, second, and third, and then stop at the 4th and don't include the 4th. So that's something to remember about slicing. Slicing will include the first numbered index, but not the last one.
Hi, it includes white space too, right?
I'm sorry, can you repeat that?
It includes white space as well.
It does include white space, yes. So
Okay.
if I took from 0 to 6, this will be the 4th and the 5th characters.
Right, thanks.
Mm-hmm. So white space and even characters like special characters that are kind of invisible characters, you know, like new lines and that sort of thing can be included in strings. I think hopefully I show an example of that in just a second. One thing that's also interesting about strings is that in addition to indexing them, like they're a list of characters, since you can index them like this, you can grab what the index is of a particular character. In this case, I'm kind of introducing a special notation. So what exactly is this dot index? Index is considered to be something called a Python method. And the dot notifies Python to call this particular method on the variable in front of the dot. What a method is, we'll come to this in just a bit, but a method is basically like a function for objects. So if you're familiar with object-oriented programming, or I guess even if you're not, an object is like a collection of data and methods. And the methods inside of the object are like functions. When I call this thing called an index, it can operate on the value of parent return, and it can look at, in this case, what it's doing is it's getting the index of the first occurrence of this particular character, which is the exclamation mark. So it's telling me that's 22. If you come back to the string and look at what the index is of this first exclamation mark, you would find the index to be 22. So we'll come back to functions and methods. This is kind of just introducing you to the fact that you can call something which is like a function with this dot notation. So we'll come back to that. If you're following along, what I'd like you to try and do, just to kind of get it a little more interactive, and for me to kind of take a break from you talking and for you to do something. Try and use this parent return dot index with the exclamation mark in combination with the slicing to print out only the first sentence of the string. To try and combine those together. And yes, so in response to the question in the chat, and just so that all of you know, in order to get some of these cells to output what it is that I'm seeing when I execute the cells, you will want to run all of the cells from top to bottom, or from top to wherever it is that I am. So unfortunately, I can't see how everybody's doing, but if anybody thinks that they have a solution, try and paste it into the chat and we'll see how it works. Very good. Thank you, Stefano. Oh, yeah, so we got an additional one too. Very nice, Ming-Chen. That's good too. So Alexis, your solution is good too. You can actually do, you can just increment the index to 23. But yours, actually, yours introduces another interesting point, which is, so I'll put yours in here.
Quick question, Benjamin. Can the
Yeah.
quotes for the index also be double quotes instead of single quotes?
I'm sorry, I'm having trouble hearing you.
Can the quotes for the apostrophe can also be double quotes instead of single quotes? You mentioned earlier that strings can be defined as double or single quotes.
Hold on a sec. I needed to turn up my computer audio. Can you please repeat that again?
For the 12, so for the indexing, so you mentioned that the strings can be double or single quotes. So I'm just asking, in the case of index here, can the apostrophe, for example, be used as a double quote?
Yes. So using this as the double quotes will return the same thing. So if instead of putting on the single quotes, I put on something like this, it will still give me the same thing. Yes, Suzanne, that is true. You can do that. My intention was to not use the 22. I mean, I've kind of cheated here a little in giving you what the answer is. The answer is just 22. But you don't have to do this. And if your string was something different, you might not want to hard code in the value of 22. You might want to use just the index of the exclamation mark to make sure that what it is that you're searching for is true, even if the string itself changed. So let me copy in one of these results from the chat. So one thing that you can do is just to say parrot return from 0 to whatever the index is plus 1, and it has to be plus 1 because it's not going to actually include, remember, it's not going to include what this last index is. So you add 1 to actually include that. When you do that, then you get the first sentence. You get, yeah, the first sentence. So this is what happens, Alexis, if you type in your answer. And I think, so you're kind of on the track to something that's interesting to point out about strings. One is that this is the main part of the string that you want. Then you do have the exclamation mark. So you do somehow want to combine these two together. Rather than putting in the comma, what the comma does is it changes it to a different variable type. This is included between parentheses because this is considered to be something called a Python tuple. A Python tuple is like a collection of different elements and you put them in between parentheses. If you want to keep this as a string and just combine the two parts together, you can use the plus sign. Oh, interesting. So I have to introduce something in addition as well. One is that this particular thing here is an integer. And this particular thing here is a string. So you'll probably run into this a whole heck of a lot when you code. I sure do. You'll run into all types of error messages because you're either doing something incorrectly or you mistype something or whatever. So it can be important to try and decipher these error messages when you actually see them on your screen. Sorry, I'm looking at one of the chat questions. How do you get more than just the first index where the character appears? Do you mean like the second occurrence of where of an exclamation mark? Yes. So there are additional variables that you can include in the call to index. So in this case, what you want to do is you want to look up the documentation for index to see what else you can put in here. So I think it's probably as simple as just including one more thing in here, and you can get kind of the, say, first, second, third, or whatever occurrence of the character. But that's, I think you'd find that just simply by looking at what the documentation is for index. Let me tell you how to get to the documentation, and after I talk about this error message. So when you're executing Python, typically it will try and tell you, it will try and give you an error message that tells you what's going wrong. And this can be very, very important to know when you're kind of executing Python code. In this case, it gives you the arrow, which points to the particular part of the code which is giving you trouble. In this case, this isn't any new information because I only tried running one line of code. But if you have a script, say, that has 100 lines of code, Python will try and tell you which particular line gave you an error. The other thing it does is it tries to tell you what type of error it is, and it tries to tell you why it's complaining. So here it tells you that you can only concatenate str, which is the Python string, not an int to string. So what that indicates here is that one of these things is a string and one is an integer. And in this case, that's true. This thing is a string, this thing is an integer. What we have to do is either convert this thing to an integer, which is not what we want to do. We want to keep it a string. Or we want to convert this thing to a string. We don't really want to do that either because this is just a number. What we actually want to do is we just want to tack on the character that we know should come at the end, which is the exclamation mark. Exclamation mark. And I'm going to show you something new here too, which is the pound sign. So the pound sign in short is how you write comments in Python code. This is a comment. If you put anything after a pound sign, it won't get interpreted by the Python interpreter. Python will just ignore it, and this is just a place where you can write notes to yourself about what it is that the code is doing, or notes to other people about how you do it. What I also wanted to talk about was the documentation. So whenever you're dealing with these methods, right, it can be good to know how it is that you figure out what it is that you can potentially do with it, or what it is that you need to put in between parentheses. One thing that you can do is you can simply type what it is that you're trying to execute and put a question mark after it. This is particularly true inside of the Jupyter environment. So here it will try and put up what some kind of help information. And what this actually grabs is documentation that's actually written into the code as comments for the particular thing it is that you're trying to execute. I'm not going to focus on this too much at the moment because we might be getting too ahead of ourselves. Another thing that you can do is you can simply type, let's see if this works. So you can type help and put the thing inside of the parentheses. This will also output the documentation for this, so index. Just in brief, to answer the person who talked about trying to find a subsequent occurrence of the exclamation mark, here you can specify what the start and the end characters are for the substring where you should be trying to find this particular character for the index. So once you know what the occurrence of the first index is, you can put that as the start, and then it'll find the subsequent index. All right, so I got a little bit ahead of myself. Here, I'll just to remind us what parrot return is. Parrot return is this particular string. When it's output, you see the Python interpreter returned it as an actual string. So it's not just the interior characters of the string, it's actually between the quote marks. You can call this function print, which when you pass something to print, it will actually print it as if you were, say, printing it as output from an executable. In this case, you don't have the quote marks, because all that you want to do is you actually want to print the value of the string without anything related to Python considering the bounding quotes. So I see there's something about something that I think I missed in the chat. But it looks like it's kind of being addressed. If you still have the question about wherever that originated, please let me know. Getting back to this, you can actually include quote marks inside of your string if you want to. This might look a little funny because it has both types of quote marks. But what it is it's saying what's bounded by the outside quotes is what I want to be the string. So outside of this are the single quote marks. Inside of it are the double quote marks. The double quote marks are actually part of the string. So when I execute this and I assign this string now to parrot return and I try to print that, then it does return to me the value of the double quotes. And this can be important, for example, if I actually do want to print this as a quote of what somebody is saying, I want the quote marks to be included. So I include the double quotes between the single quotes. And since the exterior quotes are the single quote marks, it knows that the double quote marks, when I put this double quote mark, it's not a termination character for the string for the single quote. So as you can kind of mix and match the quote marks like this. You can keep the exterior quotes to be double quotes, but you have to include an escape if you want to include the double quote in a string that you've delimited by the double quote. This is just to show you that how to put quote marks into a string where you use the same quote mark inside of the string as what you're using to specify the outside of the string. And then those escape marks allow you to put kind of special characters into these. So this /n will give you a new line. What this first part is it's simply a quote mark that's been escaped with this sentence bounded by the ending quote. It puts in this character, which is the new line character, and then it gives you the second sentence, which is also bounded by quotes. So one final thing about strings. Strings you can actually treat in some sense like a value that you can manipulate with mathematical operations. So if you have this particular string, spam, and you try and multiply it by 3, Python knows to interpret that as the fact that you want this particular string 3 times. And as I mentioned previously in response to one of the questions, you can also use the plus sign. This will give you spam 3 times plus the following string. So you can use these mathematical operators in between strings. I'm going to skip over this exercise, but just kind of one thing to remember is that sometimes it's easy to forget that, say, adding two numbers together is different than adding me to the list of instructors you've taken a workshop from. Addition, in some sense, can mean different things depending on the context, just in language. In the same way in Python, the plus sign and the asterisk can mean different things depending on the context. And it's intended to be written as an kind of intuitively understandable language. So the meaning of the plus sign can be ambiguous and depend on the particular context in which you find yourself. So I'm going to skip over the exercises and just go straight to list, because I want to make sure I get to some things like defining functions. Kind of yeah, is there a question?
Yes. How do you just add like another line that that you just want to incorporate within, say, like the list section?
You mean a separate line like this?
No, not like backslash n, like line 20, like a line in between 28 and 29.
Oh, you mean it's a different cell?
Yes.
You can use this plus sign. That will give you another cell. I'm using the keyboard shortcut, which you have to be in command mode, which means that this left bar has to be blue. If the left bar is blue, you can use keyboard shortcuts A and B.
Okay.
A will insert something above it, and B will insert something below it. A new cell.
Okay. Thank you.
Mhm. All right, so getting on to lists. A list is a collection of items which is bounded by square brackets. In this case, what we're, this is taken from Monty Python and the Holy Grail. But so in short, a list, we've already gone over kind of indexing strings and slicing strings and getting subsets and calling methods on strings. You can think of lists in a very similar way, only now it's not a collection of characters. It's a collection of, in this case, of integers, or you can have a collection of, these elements can be strings, these elements can be floats. You can actually mix this up and have different data types and different indexes of the list. But the basic idea, usually Python lists are all kept to be one variable type. And they're simply comma delimited and bounded by the square brackets. So when I define holy hand grenade by 1, 2, 5, I can index it in the same way that I was showing you to index strings, where there's 0 index. So the 0 character is the first element, which is 1. Index 1, this is 0, 1, and 2. So index 1 is the element 2. You can't index past the range of whatever number of elements that you have inside of the list. So if you try and index outside of the range, Python will give you an error message. However, kind of interestingly, you can index with negative numbers. So -1 will start counting from the end of the list. Indexing with 0 is already taken up by indexing what the first element of the list is. Going in the negative direction, this is -1, -2, and -3. So we get, for the negative first element is the last one. -3 is going to be 1. And also, if you go too far in the negative direction, Python will also give you an error message. You can't index outside of the range of elements. We can do slicing similar to what we did with strings. So here I'm slicing with negative numbers. So you kind of have to think of things in reverse. But the -3rd element was the 1. the negative first element was the 5. So in the same ways with strings, it includes the first index element and goes up to the last index element, but does not include the last index element. So this is just 1 and 2. We can index up to 0, which goes past the the last one. But in this case, you know, there's some ambiguity as to how Python wants to order the positive and negative numbers. So if you index negatively like this, you don't want to include positive numbers here on the end. But there's kind of a shortcut. You'll find if you work with Python a lot more that there are kind of a couple shortcuts which make things easy to type. And in this case, if you don't include a final index, but you still include the colon, Python knows that you want to do a slice, and you're leaving it up to Python to specify what the last element is. So it just assumes you want to go all the way to the end of the list. So in this case, indexing from -3 to something arbitrary will give you from the negative third element, which is 1, up to the end. Yes, in response to the question, holy hand grenade 0 is equal to holy hand grenade -3. Yes. If you specify, if you don't specify the first as well as the last one, Python will just assume that you want to return the entire slice that includes all of the list. So you can also do this with holy hand grenade. If you don't include the first, but you do include the last, this will assume that you start at the beginning of the list and go up to whatever element you have here. So I've told it to stop at the first one. So it only includes, or stop at index 1. So it will return just index 0, which is 1. Just to remind you, I'm just going to put this here again so that we have in hand what's in the list. Element number 2, index number 2 is 5. You can assign values to certain elements in the list just with the regular assignment equal sign. And now if I list the list, it converted that element at index number 2 to the value 3. So 1, 2, 3. You can also assign an entire list back into this variable. In this case, I've converted the numbers into strings. So here you can see that I'm using strings instead of integers. And now I'm going to show you a couple different methods that you can call on this. You can call a method called sort. This essentially applies a sort function to the collection of elements that you have in the list. If they're alphanumeric strings, what you get back is just an alphabetical ordering of the strings. So here F comes before O before T. You can also reverse it. Reverse it just gives it back to you in negative of the sorted order. And as I mentioned above, it can be interesting at sometimes to call help on things that you want more information about. Here it's just, this is the complete help documentation for lists. When you type help and you're just kind of a beginner in Python, you can ignore these things that have the double underscores kind of before and after the method name. The important ones that you want to focus on at first are those that don't, these are kind of built-in methods to the objects. Just focus on the ones which are like a regular string of characters. So here I have index, which we looked at before to get the index of a particular element in the list. You can append objects to lists. This also gives a description of what the method does. Clear removes everything. Count, you can get the number of occurrences of a particular value. And then we have kind of the sort that I pointed out up above and reverse. So simply calling these on a variable will return to you the documentation for whatever variable type it is that you're working with. If you see something in here which you will also want documentation about, say pop, this one here, I could change this to pop, and it will give me the help documentation about pop, which in this case will remove and return the index, the item at this particular index, which is by default is the last one. So I can show you just calling another method, a method with append. You can append items to the list, or you can look at documentation. This is another way, by the way, to get the documentation for something, which I'll just leave you to explore that in a little bit later on yourself. But I've talked about the question mark and the type function. So I'm going to take just a brief pause just to give you a little bit of time to kind of play around with this just a little bit on yourself. Try and make your own list with 5 or more elements, and then try and use the pop method on it just to check and see what pop does. I'm going to take a little break to get some water, but I'll be back. All right, sorry about that. I just had to get some water. Are there any questions? So I'm going to I realize I'm running a little short on time. What I'm going to do is I'm going to go rather quickly through this next description of tuple sets and dictionaries. The basic idea here is that there are different ways of specifying collection of elements in Python. By far, I'd say that the most important ones are the list and something called the dictionary. So as I've shown with lists, you can have a collection of elements that are specified in between square brackets. I mentioned tuples briefly as something that's specified in between parentheses. What you'll find if you simply run these cells, this specifies the tuple, what's called a tuple, which is in this case a collection of strings. You can still index tuples. What you'll find is that you can't assign a value back into a certain element placed inside of a tuple. And that's because tuples are immutable objects. Unlike lists, which lists are mutable, tuples are immutable. And tuples are intended to be, there are reasons that they're immutable. It kind of, if you want something to be very efficient, you want to make sure that it's not going to change over time, say, then you make it immutable, and your code can be kind of optimized, say, because you're certain that the data variable isn't actually going to change. Say that's one reason that tuples are immutable. But you can have tuples, just like with lists, you can have different data types inside of the tuples. Certainly, if you want to read more about any of these data types, there's lots of documentation online. And I'll kind of point to some documentation resources at the end. In addition to tuples, there are sets. Sets are specified by the curly braces rather than the parentheses or the square brackets. And sets are intended to be just like mathematical sets. So there isn't an ordering to this set. All that a set is considered to be in Python is just like a big bag of whatever collection of elements you have. Yes, that's correct. So there was a question about what immutable is. And immutable means just that once you assign a value to the variable, then that variable can't be changed. The elements of the variable can't be changed unless you actually reassign a different value to the variable. In this case, I tried to index something inside of a set, and I can't because that's not how sets work in Python. A set is just a collection of elements. You can test whether something is inside of a set with this in keyword. So just like I mentioned that there was the keyword not, there's the keyword in, which will return true or false. In this case, blue is an element of the set. That's called riddle answers. And then you can have methods for sets. For example, you can test unions, intersections, kind of things that mathematically you would be able to expect to do with a set. So I can add green to it. If I add blue to it, blue is already in the set, so the set itself, the values that are inside of the set don't change. This is a very brief introduction to sets. And then there are dictionaries. And the reason that dictionaries are kind of so widely used in addition to lists is because, in contrast with lists where you index with integers, lists are ordered, say, an ordered collection of elements. With dictionaries, you index elements by variable names. So in this case, I've specified the dictionary like this. This is the name element of the dictionary. This is the quest element of the dictionary. This is the favorite color element of the dictionary. When I can't index a dictionary with an integer. There's no ordering to this dictionary, but I can index the dictionary with, these are called keys. So keys are name, quest, and favorite color. And then the values are Lancelot, Holy Grail, blue. Dictionaries are a collection of key value pairs. So I can index the dictionary with one of these keys, and then it returns to me the value for that particular key. And I can print out the keys and I can print out the values. And then in the interest of time, I'm going to skip over these exercises as well. But I'll fill out all of these exercises and provide them to you as a notebook after the class, just in case you want to try and do the exercises you're on your own and compare them, say, against what a possible answer is. When I was going through the interpreter, I already mentioned all of the conditional expressions. So something else that's important to do with Python is to kind of control the execution order of your program and to only execute certain things if something else is true, say. So the first thing that I'm going to talk about is just executing an if condition. This is how you write the conditional if statement. So what this says is if 3 is equal to 4, this is our Boolean condition, which returns true or false. After the if condition, you put a colon. And then if you put the statement on the next line, it has to be indented. And you type in what it is that you want to be executed after if this conditional is true, which is that 3 is equal to 4. So this condition is not true. When I execute this, then nothing actually gets executed, but because the condition is false. If the condition is true, then it does go and execute what is on this line. So in this case, it prints the string. This is self-evident. For the question, where will this recording be available? I'll send you a link once I've posted the recording online. It's important to note in this particular example, the indentation. So one of the very important things about Python is that it uses indentation to define blocks of code. It's not just a matter of style in Python, it's actually very important for defining a block of code. If you go into this cell and you move your arrow button, you'll see that there are 4 spaces which are before the print. If I put in a different line, print this too. So it prints both of these, or it executes both of these lines because both of them are considered to be part of the block of code, which is executed if this condition is true. If I came up to this one, where 3 is not equal to 4, this is the block of code. So Python execution would skip over both of these statements because they're both part of that block of code. If I didn't have the right indentation, it would only consider this to be part of the if block of code, not this one. So this is the block of code associated with the conditional. It executes this first, and then it goes on and considers this to be a different part of the code, and it would execute this separately. There's the question, how does the terminal relate to the notebook? So the terminal you can think of as the interface for interacting with the operating system. This Jupyter notebook itself, you can think of being more like a physical notebook, say. So if you have a physical notebook that you're carrying around with yourself, you can jot down sentences on pages in the notebook. Say you can paste in pictures. Maybe you'll take a plot that you generated from an experiment that you're running and paste it into the notebook. This Jupyter notebook contains kind of documentation in line with cells which are executable. So the Jupyter Notebook is something that's like an interactive coding document. But the Jupyter Notebook itself, this may be more than you want to know. So if I navigate into my, here I'm interacting with the terminal. So all the things that I'm typing at the terminal prompt are shell commands. You don't have to worry about what VI is, but VI is like a text editor. If I look at what's actually inside of this file, this is actually what's inside the contents of the Jupyter Notebook file. A Jupyter Notebook is just something called a JSON file, which is kind of like a big dictionary of things. But the Jupyter Python program itself knows how to read in this notebook and then render it here on the web page for you. So the notebook itself is simply a file of text. When you execute something here, the web environment knows to take these commands that I've put here inside of the document and then send them somewhere else to a different part of the operating system, which executes the code, and then it returns it back to the web browser. So the notebook itself is more like an interactive web-based coding environment. The terminal itself is actually interfacing with the operating system. And then the Python code that I ran inside of the terminal, when I type Python, this is, I type Python because I'm telling the operating system to run the Python interpreter for me. And so the operating system starts up the Python interpreter, and then the commands that I type here are executed by the interpreter program that's running. I'll show you something different here, which I also included in your documents. Since we're getting close to the end of time, this is probably important to show. So if you look at the interior part of hello.py, I'll just show you what this is. You can actually, let's hide this. If I come back to my menu and I click on hello.py, it will open up a separate tab in your window, which should be like a text editing window. It's a very simple text editor. All I want you to do is just see what it is that's here inside of this file called hello.py. What it is, it's a line of code that you could say, type into the Python interpreter, and if you typed it in, what it would spit back at you is just hello world. This is the Python command to print a string. If I come here into the terminal, another way that I can run Python scripts is by typing Python, which is for the Python program, and then typing the name of the script that it is that I want to run. When I type something like this, the Python interpreter isn't going to be started. Since I've included the name of a Python script here, when I include that after the Python and I execute that, the Python program will know that I don't want to start it up in the interpreter. What I want it to do is run the Python code that's included in this file. So this is another way to run Python programs. You take all of the commands, say I could collect all of the content from the executable cells inside of the notebook and paste them into some text file, which I put on the suffix of .py. And then I could say Python and then that file name .py, and it will run all of the Python commands that are inside of that file. So this hello.py is an example of what a Python script is. Let me show you something that's a little more advanced. So this, you don't have to worry about what any of these commands are. This is just to show you another example, kind of a shortish Python program, which has, all you have to think of is it's a collection of different Python commands that you can execute. So that's a Python script. I can execute it with Python and then the name of the script. And then it's going to execute all of the commands that are inside of that file as Python code. What it does underneath of the hood, what that script does is it generates a plot, this one called apple.png. So if you come back to subsequent parts of the series, you'll kind of get more exposure to this. But what it's doing right now, it's plotting the time series history of Apple stock over the last year, 2020. So this bit of script, let me open up that script, stockplotter.py. This script, what it does is its ultimate result is to make this plot. I don't know how many of you have more time to stick around. We are getting to the end of the time. I'm going to continue talking for just a while because I want to talk about what it means to define functions and what it means to have a module file like this. So if you want to stick around, you're welcome to. I'll continue recording and just make the recording available to everybody. I apologize for running a little short on time here. But for those of you who still want to stick around, I'll continue going for just a little while. So I was talking about indentation. And so indentation is very important. And kind of as a final note about this, you don't want to mix tabs and spaces. Python will complain at you if you try and do this, or it may give mysterious results. But you want to make sure that all of your indentations are the same number of tabs or spaces. So you want to be consistent in your program so that Python knows how to interpret blocks of code that you're writing. So in addition to if, you can specify a subsequent condition that gets evaluated if the first condition isn't true. So in this case, it checks if 3 is equal to 4, which is false. It goes to this, and the ELIF is like an else if. So if this is true, this gets executed. Else, if this is true, this gets executed. So 3 is not greater than 4. So actually neither of these are true and neither of them get executed. If 3 is equal to 4, this gets executed. That's not true. Else, if 3 is less than 4, this gets executed. That's true. So what this should do is print 3 is less than 4. You can have any number of these else if conditions that you want. But then you can have a final condition which gets executed and nothing else above it is true, which is your final else condition. So this says if 3 is equal to 4, you print this. Otherwise, if this is true, print this, which is not the case. And if none of those are true, this final else statement, then you print this. And so in this case, 3 is not equal to or greater than 4. That's what gets printed. So this is an introduction to the if, else if, and else kind of conditional statements. And so in addition to the not keyword, you can combine multiple of these conditions together. Python makes it easy, so you just spell out the word and or. So here I've said the variable claim to be equal to 5. And this says, if claim is equal to 1 or claim is equal to 2, you print this. Otherwise, if the claim is equal to 3, you print this. Or if the claim is equal to 5, then you print this. And if none of those are true, then you print this. So from this, you can just kind of get a sense that some of the Python code that you come across is just going to be kind of readable right off the bat, even if you aren't necessarily certain on the exact specifics of what the syntax is. This is rather obvious. So claim is equal to 5. So this is not true, this is not true, this is true, this is what's get printed. And then the else doesn't get executed if something earlier is true. So this print silly author 3 comes after 2. The other two things that I want to talk about are while loops and for loops. So I'll mention these before I get to the functions. The while loop executes another block of code depending on, well, it executes it as long as a certain condition is true. So here I have Disney trip is equal to, is assigned to the value 0. And I say, while Disney trip is equal to 0, you print this. And if you're staying on top of this, this is something that I don't really want to execute, but I'll execute it anyways. So this never modifies the value of Disney trip. So there's no opportunity for this to become different from 0. So it's just going to keep on executing and executing and executing. This is an infinite loop, and you want to stay away from these. If you've actually come to this cell and you try to execute it by yourself, just click on this box, that'll stop the execution. This is an infinite loop. So you do want to somehow modify the variable that's getting evaluated in the condition for the while. So this says, while Disney trip is less than 10, then you execute this block of code. So you print the value of Disney trip plus this string, and then you increment Disney trip by 1 for each time that you go through this. I'm going to execute this just to show you again. This is actually the exact same error that we ran into earlier, where you can't concatenate something that's considered to be an integer with something that's considered to be a string. So I can cast this. I can cast an integer as a string by this str function. This casts an integer to a string and allows me to concatenate then a string with a string rather than an integer with a string. So the first time through the loop, Disney trip is 0, and I print 0, are we there yet? And I increment it. And as long as Disney trip is not incremented to be equal to 10, then it prints this out. And once it is, it stops. So then the for loop, this is the last thing I'll be talking about before we get to the function. For loops are kind of also written in a kind of very readable way. So Disney trip, here I'll show you this. So range 10 is a way of specifying to the for loop that I want to iterate over the numbers from 0 up to whatever's in between the parentheses. So 0 up to 10. But kind of true to the Python syntax, this actually won't include 10. It will stop before it gets to 10. But for every element that's in that range between 0 and 10, it prints out this string. Just to remind you what's in parent return. Parent return is this string now, which is kind of an interesting combination of things. But I can also iterate over every single character just with a very simple for loop. I say for some variable, which here I've called to be letter, in parent return, print it out. So it's going to iterate over that string. And for every character that it finds, it's going to print it out. So for loops end up being kind of very intuitive. This just shows you how if you don't want these to be on successive different lines, you can print them all out together by just saying that the end of the string that should be printed is there should be no character that gets printed after this string. So that prints it out kind of in a more readable format. And then you can also iterate over dictionaries with for loops. If you do something like this, where you say for k and riddle answers, this would be like iterating over all of the elements in the collection. What this will do is it will iterate over the keys. So the keys are name, quest, and favorite color. You can print out the values for those keys just by kind of indexing the dictionary with the key. That will print out all of the values. And kind of importantly, when you're iterating over dictionaries, you can iterate over all of the key value pairs by calling the items method on your dictionary. So the items method will return all of the key value pairs. And then this is kind of an interesting Python syntax too, where you're writing this almost as if you're just writing it out by hand. This is for every pair here gets assigned into a pair here. So this assigns all of the keys into the key variable and all the values into the value variable. So rather than writing key and value, I could just say K and V, or I could say A and B. It's just the fact that two things are getting returned by items, the key and the value. And then I print them out. So I've gone through some of the more complicated things about the for loops. Probably all that you want to do is just iterate over some range of numbers, which is relatively easy to do. And you can specify a range that doesn't start at 0 just by including the first and the last element. All right. So I'm going through this quickly. I hope it's not too quickly, but it does give you a flavor for what's going on here. So for functions, someone had asked about functions earlier. Functions are very important things when you're interacting with Python. So this is where the question came up, actually. It was when I wrote out something to evaluate the value of this function. So ideally, what we'd like to do is we'd like to plug in a bunch of different numbers and see how the value that's output changes as we change the numbers that we put into it. So what a function does is a function allows you to collect together a block of code. You name that block of code, and then you can call that block of code by calling that particular name, the function name. And you can pass data into functions, like you can pass in the value for different variables, and then results get returned back to you once the function gets evaluated. This is a very standard kind of example, just printing hello world. When I execute this, nothing happens. What this is actually doing is this is defining the function. So DEF for define, F is the function name, and then you have to have the parentheses. This is empty because it doesn't take any input parameters. But you could have any number of parameter names inside of this. And then you have a colon, and then you have your block of code that gets executed when you call the function. So remember, blocks of code have to be indented. In this case, it's by the 4 spaces. And you call a function just by calling that function name along with the parentheses. So the parentheses have to be there so that Python knows to evaluate this as a function. When I call f, it just prints this string. And I can say define a second function that actually has a parameter in here, a. And what this is going to return is just that parameter, whatever it is that I pass into the function, multiplied by 2. If I just write this, f2 without the parentheses, what Python is going to return to me, it's not going to try and evaluate the function. It's just going to tell me that f2 is a function. So I have to specify to Python that I want to call the function by writing down the parentheses, and then in between the parentheses, I can pass in the parameter. I can either pass in directly a value, in this case 3. So this returns 3 times 2, which is 6. Or I can explicitly specify the parameter as being assigned to a particular value. This returns to me 4 times 2. And this parameter has to match what it is that I specify in the function definition. So for example, I could not specify b is equal to 4 because it would give me an error that there's no keyword in the function definition, which is b. It has to be a. All right, so now getting back to our example with the investment balance. It's actually rather simple. This is just what we want to return, the evaluated function. And then these are the parameters which we want to pass into it. So that's our function definition. And once we've defined the function, we can assign values to the variables, pass the variables into the function, and then evaluate the function. So these cells all execute rather quickly, but these are just executing the function with different values for the variables. And then, so you're welcome to look through this later as well. This is just showing you that you can put additional bits of code inside of the code block for the function. In this case, I'm dividing the rate by 100 just so that I can specify the percent rate. Here is 5%, and it gets scaled by the factor of 100 for the formula. And then I'm printing out a string, which says how much it is that I've saved after a certain number of years. So you can have any number of executable lines of code inside of the function definition. You'll need the return at the end if you want to return something, or you'll need something to be printed if you just want the function to have an indirect outcome. And then I have a little note here too about seeking help for Python. So say we've come to this and we see this number and we want to specify commas in the number because this is a dollar value, you know, and we like it to have comma values in the thousands and the millions. Google is actually a fantastic reference for asking Python questions. So I'll just show this here. And put commas in number Python. Usually, if you put Python and a very terse description of the issue it is that you want to address, you'll almost immediately come to somebody who's asked this question before, and that you can reference and grab the bit of code that you need to put into your own code. A lot of times these are taken from a website called Stack Overflow. Stack Overflow is a place where people can ask coding questions and experts can offer up answers for how to do things. In this case, you know, we got to something which says, well, I haven't talked specifically about string formatting, but it tells you how to put in the comma into the string so that you get something which looks like it's delimited by commas in the thousands and millions place. I definitely invite you to look over this a little bit later if you're interested. On the particular one that I've linked inside of the notebook, you also see if you go down to the first answer, there's a link to something called PEP and something to the official docs. So PEP, if you click on that link, will take you to the python.org site. And PEP is in particular the Python enhancement. I forget what the last P is. Python enhancement proposal maybe. But the PEP in particular with a particular version will give you some of the style guidelines for Python. The official documentation for Python, which you'll find on the link for the official docs, is actually a very kind of nice place to read about some of the functionality of Python if you'd like to learn a lot more about how these functions work. So there's a question, can I show how this works in a text file where this is the main code? So let me go back to this. So I don't expect you to know everything that's going on inside of this. But one thing that you can recognize is that this is a function. So this is a function definition of a function that's named getSymbol. And symbol is what's passed in as the parameter. Actually, we can start to decipher some of this. So this particular thing, the thing in between quotes is a string. This particular thing called .format calls a method on the string. And what it does is this particular place where it has the curly braces, this .format tells it to insert the symbol into where the curly braces are. And then that string gets assigned to the variable. The end result of all of this, you can see there's a for loop, which iterates over things that are inside of basically this dictionary. So it's a dictionary which is indexed by keys that are strings. In this case, it's kind of a multi-level dictionary. There's an if condition, and if that if condition is satisfied, then it returns this particular value for the X, what is kind of in this X part of the dictionary. To tell you what happens behind the scenes, if you pass in the stock ticker symbol, say AAPL for Apple, if you pass in the symbol, then it will return to you the name of the company that corresponds to that stock ticker symbol. So here's where the function definition gets put into the file. And then the function is just called here, getSymbol AAPL. And what getSymbol.aapl returns then is the company name, Apple. And this particular block of code, don't worry too much about the specifics, but what it does is it generates the plot that I showed you for Apple. This one here. This particular part of the code is well, I'm showing you the same thing just now in the text window. This particular part of the code is calling functions that are in the matplotlib library. So you may have heard of matplotlib. Matplot, when you do something like this called import matplotlib, it makes available all of the data and functions from the matplotlib package. In particular, what this does is it generates the figure. This part here calls the plot function, and this is like just calling plotting X versus Y, which in this case is the dates versus the high values for the stock. This is the function to set the title. So when you set the title here, this is the company name. So the company name is the result of calling this function with this name for the symbol. And so that company name gets passed into set title as kind of the value for set title, and then gets set as the title for the plot that's generated. And then this just formats the dates so that they have kind of, they're oriented like this. If they were oriented horizontally, that they'd all overlap with each other. And then this save figure is a function inside of matplotlib, which then saves the plots that's generated here as this particular file name. The basic idea is just like inside of this notebook, where I'm defining, here I have a function definition. That's the function definition, and then I call the function just like this. You do exactly the same thing if you want to execute a function inside of a file. So someplace you have to define the function if it's not imported from other libraries. And then you just call it with the name of the function, and you pass into it any necessary parameters. Some of what I've described here is also described in this final part of the notebook, which I'll go through very briefly. So a module, a Python module, is like a library book that you take out, and it contains code that you want to use. You can write your own text files that you can call your own module files that include, say, functions that you want to save and use later, or variables that you want to associate with the code. And then you can fetch a module using this import statement. And once you use the import, all of the variables and functions will be usable inside of the code that you're currently running. And it's therefore it's very useful to share these modules with other people, to share code with them, or to take code that other people have written and use it yourself. So this my module that I have here is a file that's here, mymodule.py. Inside of mymodule.py, I've put the function definition for compound calculator. This is just a string to document what compound calculator does. And you can tell by the indentation where the block of code ends. So all of this stuff, which is indented by the 4 spaces, is part of the function definition for compound calculator. These are the 2 kind of lines that get executed in the function. This just modifies the interest rate, and then this prints, it prints this string, and then inside of these curly braces, I showed you before that format puts kind of the value in between parentheses into whatever is inside of the string in the curly braces. This particular notation here is just for formatting the string that gets put into it. But here's the function that gets evaluated when you pass in P, R, Y, and C. This gets evaluated first, it gets formatted, it gets put into the string, and then this string is returned when you call the function. Into this file, mymodule.py, I've also put in just variable definitions. So one for holy hand grenade, one for our dictionary for the riddle answers, and then one which is just a long dictionary for stocks that are on the Dow Jones Industrial Average. When I come back to my file and I import this, calling the function dir and the module name will tell you everything that is inside of the module that you just imported. So here you can see compound calculator, holy hand grenade, riddle answers, and the stocks dipped. You reference what's inside of the module with this dot syntax again. So putting in what the name is that you've imported, which here is my module, and then dot holy hand grenade, we'll get the variable that I've specified inside of that module file, 125. And then say I can do things with those variables. This is just iterating over the length of this variable and printing out what the value is, 1, 2, and 5. This specifies just renaming what it is that you import. So I can call my module something different. It's called aliasing it. So I can call it say if I don't want to type my module every time that I reference the module. So now well, here I also renamed HHG for Holy Hand Grenade. Right. All right, I'm going to skip over this for the moment, just since we are very much at the end of time. But just to show you, you can execute functions that you've put into that module file. My module.py includes the compound calculator, so I can call the function that's defined inside of that module file basically by importing it here. Just import my module, and then my module dot the name of the function that you've defined inside of that module file. We'll call that function and execute the code with these parameter values, and then return to you the result of executing that function. So when I get to something like this, this is the NumPy library. So I import it, and this is kind of a conventional shorthand. I call it NP rather than NumPy. And I call this module pyplot, I call it PLT rather than matplotlib.pyplot. But when I say import, I import I kind of suck in all of the functionality that's defined inside of the module files for these particular packages. And then I can call the functions that are inside of those modules. So np.linspace calls the function linspace that's inside of the np module. That basically defines a NumPy array. I'll reference this in the next one. This defines another NumPy array, which is just, in this case, this is 1,000 values between 0 and 2 pi. This is, for all of the values in this array, it evaluates the sign. And then I can plot it. I call the plot function in the PLT module, and it plots t versus y. So this has kind of been going super fast, I appreciate. But I hope that it's given you a lot of the flavor of some of the Python and gotten you up to speed enough so that you can kind of explore much further on your own to hopefully become a little more proficient with the Python if you're interested in pursuing it further.